Hi students, it's Mr. Nguyen again, coming back with another example on how to solve a system of two equations and two variables. Here we have a system of negative 16y equals 22 plus 6x and negative 11y equals to 4x plus 15. The elimination method would be the best method to use here, simply because none of the variables are single or by itself. Elimination, okay? So I'm going to show you how to use eliminations to solve this. So notice the equations are not written where they are lined up, right? So the y variables are lined up, but the x variables are not lined up. So my job here is to line them up. So I'm going to keep the first equation the same. So negative 16y equals 22 the same, okay? What I'm going to do is I'm going to take the second equation, so equation 2. Equation 1 stays the same. Equation 2, I'm going to just simply switch these, right? I put the 4x back here so that it matches up with the 6x. And then the negative 11y stays the same. And then the 15 comes to the front, okay? And then this will be plus 4x, okay? So now that they're lined up, the system is lined up, you can now try to eliminate one of the variables. Well, if you notice, the coefficients for y variables are pretty big versus the coefficient for x. So x would be the better choice to eliminate, okay? In order to eliminate, they have to be common, which means they have to have the same coefficient, and they have to be opposite, right? That means if this is positive, this has to be negative, okay? And to make them common, well, one of the common multiples that these two things have is 12. Right? 6 is a factor of 12 and 4 is a factor of 12, which means I could multiply both equations by some numbers to make them both 12 and negative 12, right? So I want this 6x to become a positive 12x, and I want this 4x to become a negative 12x. So with that being said, I'm going to multiply the first equation by 2, because 2 times 6 will give me 12, and multiply the second equation by negative 3. All right? Negative 3 times 4 would be negative 12. So here I went ahead and multiply both equations by these numbers, and this is the result that I got. You can check my math. Now that the x variable matched up, you can actually eliminate them, right? They become 0. And then you simply add the rest of the terms. So negative 12y plus 33y is 1y. Equals 44 plus negative 45 will give you a negative 1. So the y variable turns out to be negative 1, okay? So after that, I'm going to go back to my original equation and say, okay, I'm going to pick one of these and substitute the negative y in there, and then I'll solve for x, right? Well, the first equation is good because x is already sort of, well, the second equation is good too. It doesn't matter. The second equation seems better because it's smaller. So I'm going to pick the second equation to solve, right? To solve for x. So negative 11 times y, well, instead of y, I'm going to put negative 1 in there, equals 4x plus 15. So I'm going to work this out. Negative 11 times 1 is positive 11 equals 4x plus 15. To solve for x, let me move this paper up a little bit. To solve for x, I'm going to have to move the positive 15 over here by subtracting 15. So I would end up with 4x equals to negative 4, and if I divide by 4 on both sides, x would be equal to negative 1, okay? So the coordinates for my intersection of these of this system, of these two lines would be, remember, we got to list the x first, so negative 1, well, the y happened to be the same, so it's negative 1 as well. So this is your solution to this system using elimination. See you guys next time. Bye-bye.